How much energy is required to ionize a hydrogen atom if the electron occupies n is equal to 5 orbit? Okay, compare your answer with the ionization enthalpy of hydrogen atom. Energy required to remove the electron from n is equal to 1 orbit. So I am left with two offers. First of all, I am told that the electron is already present in n is equal to 5, fifth orbit, and I am asked that from fifth orbit, if I have to totally remove it means I have to move it to infinity. Oh wow, just let me write it down. If I write this, it looks like, well, initially, if you remember N1, N2, N1, what is N1? N1 is the initial orbit, N2 is the final orbit. So N1 is given to me as 5, N2 is given to me as infinity. Fascinating. I'm supposed to find energy. Can I find energy of electron in any given orbit? Do I have a formula? Yes, I do. And what is that? Energy of electron in nth orbit is E naught z square by n square. E naught is energy in the first orbit. Okay? And E naught has a value. E naught is minus 13.6 electron volts. I have remembered this value. It's a standard formula which I'm going to use in Bohr's theory. So energy of electron in hydrogen atom or hydrogen-like atom in nth orbit is E naught, which is minus 13.6 electron volts, into Z square, Z is atomic number, and N is the orbit number. So E5, how much is that? This is E naught into 1 square by 5 square, which is E naught upon 25. Wow, that looks really small. And how much is that? Well, that would be minus 13.6 by 25. Fine. And how much is that? Multiply and divide by 4. So 6 was 24 and 4 ones are 4. Right. So this comes out to be 0.544 electron volts minus. So E5 is so much, and E infinity will be, well, E naught into 1 square upon infinity square, which is 0. This is good. This is easy. Yes. So delta E, change in energy, is E final minus E initial, which is E infinity, minus E5, which is 0 minus 0.544, which is plus 0.544 electron volt. How much of energy is required to ionize a hydrogen atom? Ionization means you move it to infinity. And in this case, if you move this to infinity, my dears, this is the result. So ionization is the first answer which I have obtained is ionization energy for n is equal to 5 is 0.544 electron volts only. Second part, compare your answer with ionization enthalpy of hydrogen atom and n is equal to 1. If you are already in n is equal to 1, now standard ionization energy for H atom is 13.6 electron volt. Why 13.6? Because in first shell the energy is E naught, which is again minus 13.6. From minus 13.6 you are moving it to infinity, which is 0. So the difference would be 13.6 electron volts. How do they compare? It is only 25th, 1 by 25 times. So you can say that ionization energy in the fifth orbit gets reduced to 1 by 25 times, 1/25th of the energy in the first orbit. So it's very small, very elementary, very little as compared to n is equal to 1. Not just that, if you want the answer in joules, can we do that? Yes, we can. Convert this to joules. How shall we do that? 0.544 electron volts correspond to 0.544 into 1.6 into 10 raised to minus 19 joules. Multiply the lovely thing and you will see this comes out to be 8.72 into 10 raised to minus 20 joules.